Give me 1 minute. Okay. Good evening, everyone. It's my pleasure to introduce today's resource person, Dr. Abhishek Patenge. Dr. Abhishek Patenge holds PhD in mechanical engineering from VIT Chennai and 7 years of academic experience at COEP. Currently, he is working as data science and AI specialist at ABB's Center of Excellence for Process Automation Digital, where Abhishek used to contribute advanced AI and machine learning based solution for predictive maintenance under ABB's Genix APM 360. His work has been recognized with the ABB's Rising Star Award. He also secured second position in ABB's Global Hackathon for generative AI project. Also, Dr. Abhishek have impressive research profile with 50 plus international journal publication and 2 Indian patents over 1200 citation. With his strong blend of academic depth and industry experience, we are honored to have him with us today. Please join me in welcoming Dr. Abhishek Patenge. Sir, over to you.
Thank you so much. I hope you can see my screen and I'm clearly audible.
Yes, sir.
Yes.
So I'm sharing my slides presentation and I'm on the first slide. So I would like to thanks Zeal College for organizing this faculty development program and inviting me for delivering a presentation related to applications of AI in mechanical engineering specific to condition monitoring, autonomous systems and robotics. So the scope of my presentation includes foundations of understanding what is AI, machine learning, and now generative AI as well. I have tried to include some demos so that you can immediately understand how the concepts are applied to solve problems using hands-on assignments. So the flow of my presentation begins with understanding the difference between traditional programming and machine learning. Then we will try to understand how machine learning differs from AI and how machines tries to learn from the data sets, followed by understanding three approaches of machine learning as supervised, unsupervised, and reinforcement learning. We'll then introduce you to a generative AI concept where large language models are applied to solve. They try to understand the problems in natural language and how they evolve over a period of time. Then we'll have some case studies related to anomaly detection, condition monitoring using large language models, followed by a demo, and then we will summarize our talk using challenges and future directions in AI machine learning. To begin with, let us try to understand what is the difference between traditional programming and machine learning. Now, usually when I start my talk, why do I go to traditional programming approach? Because we all are practicing traditional programming since ages. Traditional programming is introduced to students nowadays in school also, where they can learn C language, or in some schools they have started Python as well. So if we see the building blocks of traditional programming that we all of us are knowing, that it includes data, that is the input that we provide to a programming language. Along with data, we supply a program as well. Uh, then it is well understood that the programs are written by programmers or human beings because they understand the relationship between input and output. So when the relationship between input and output is explicit, when it is known, the programs or rules can be written manually. And that's why this goes with an approach called as traditional programming. So you supply data and corresponding program to a programming language. Then programming language will process this data according to program, and finally it will give you corresponding output. To take a simple example, let us consider a data set which includes two variables as a and b. We'll consider four observations of a and b as data. As you can see on the screen, the first observation for a and b is 2 and 3. Then we have 4, 2, 5 and 3, and lastly we have 1 and 1. So this constitutes your dataset. Now, along with dataset, we will feed a program to this programming language. Let us consider a simple program as C is equal to A plus B. Now, you will write a simple code using a logic which will be iterated for 4 times, and finally you will get output according to a program which is C is equal to A plus B. So when we apply this program for first observation, the output is 5. So 2 plus 3 is 5, 4 plus 2 is 6, 5 plus 3 is 8, and 1 plus 1 is 2. So here the programmer knows what relationship exists between input and output. That's why he was able to write a program, and that's why this is considered to be an approach where we deal with traditional programming, where the program is written by human beings. Now, when we go for machine learning, you will see that the building blocks are same. We have data, output, computer, and program. But if you observe carefully that now we are feeding data and its corresponding output to a machine learning algorithm or to a computer, and then this machine learning algorithm or a computer tries to understand what relationship exists between data and its corresponding output, and then finally it expressed this relationship in terms of programs or some mathematical relationship. So the term machine learning is self-explanatory because it tells you that machine is trying to understand patterns out of data set. That's why the term is called as machine is learning patterns, or machine is trying to learn patterns out of data set. So this machine learning algorithm or this computer tries to understand what relationship exists between data and its corresponding output, and finally it expresses this relationship in terms of programs or a mathematical relationship or some rules. Now let us take example. So when do we use machine learning approach? So relationship between input and output is not explicitly known, but you have a data set where you have set of inputs and corresponding outputs. Then you try to learn patterns out of data sets through computer programs or through machine learning algorithms. Now to take simple example, let us consider data which has input features, three input features. The first input feature is speed of vehicle, which is measured in meter per hour. Then we have acceleration, which is measured in meter per second square. And the third feature, that is X3, we have distraction level, which is measured from the scale of 1 to 10. When the value of distraction level is near to 10, close to 10, that indicates that the vehicle is distracted from its original path. When the value of distraction level is close to 0, that indicates that vehicle is not diverted, it is following whatever expected path it has to follow. So data set that we have here is we have three input features as x1, x2, and x3 as speed, acceleration, and distraction level. And along with these three input features, we also have output, which is also called as label or driving state or a class, and it is expressed in terms of y. So again, we have here three kinds of output. One is normal driving, second is aggressive driving, and third is distracted driving. Now, the dataset that we will provide to this computer or to machine learning algorithm comprises of three input features and three driving states, which will serve as output to a dataset. The meaning is each observation of speed, acceleration, and distraction level in the dataset either represent it as normal driving, aggressive driving, and distracted driving. Now, when we supply this complete dataset to a machine learning algorithm, it tries to understand the relationship between these three variables and these three driving states. And finally, it will give you rules with which a new dataset is either classified as normal driving, aggressive driving, or distracted driving. So we'll take a demo now. I'm going to introduce or I'm going to give you a demo on software called as Veka. So you can note down the name of software, which is open source free software. The name of software is Veka, and it is introduced by University of Waikato, New Zealand. So, so if you go to Google, okay, just give me a minute. Okay, so if you go to Google and type Veka, you will see the link with which you can download the software. So name of the software is Veka. It is machine learning software and developed by University of Waikato, New Zealand. The beauty of this software is you need not write a single line of a code, but you will be able to build a complete machine learning model. So this is zero code machine learning software. So if you click on first link, you will navigate to a page where you can see that the option for downloading the Veka. So if you click on download here, you will be able to download this software. Okay, so the beauty of this software is this is open source free software. You need not pay any subscription amount. And the second is it is zero code machine learning software. So this is meant for basically non software engineers like mechanical, civil, or electrical, where you need not have the coding skill. I mean, you don't need coding skill to build machine learning models, and that's why this actually will give you confidence about what exactly machine learning and how it works for solving problems from your domain. Now, before building a model, so I have installed this software already on my system. This is the symbol of the software, and this is how the GUI, graphic user interface of Veka looks like. Now, before going to this software, I will introduce you to the dataset that we are going to feed, which I have just now explained. So if you see in this dataset, we have four columns. In first column, we have speed of vehicle. In second column, we have acceleration. And in third column, we have distraction level. If you observe fourth column carefully, you will see that a label or a driving state or a class is included in the last column. And there are three types. First is normal driving, second is aggressive driving, and the third is distracted driving. Now, what is the meaning of this data set? Each of this observation of speed, acceleration, and distraction level represents class either as normal driving, aggressive driving, and distracted driving. You can assume that this data set is collected through sensors which are equipped or which are connected on an vehicle or on a vehicle. So how many total observations do we have? If you want to understand, then you can just filter out this data. So when you click on only normal driving, you will see the count. So there are 50 observations. So that means there are 50 values of speed, acceleration, and distraction level, which indicates that the driving state is normal driving. Similarly, for distracted or aggressive driving, we have 30 samples or 30 observation. That means these 30 observations or values of speed, acceleration, and distraction level indicates that the driving state is aggressive driving. So 50 plus 30, now we have 80. And lastly, for distracted driving, how many observations we have? We have 20 observations or 20 samples, which indicates that the speed, acceleration, distraction level corresponding to these 20 observations are representing distracted driving. So initially for normal driving, we were having 50 observations. For aggressive driving, we were having 30 observations. And for distracted driving, now we have 20. So your complete data set consists of 100 observations in total, which represents the data point which consists of three variables as either normal, aggressive, or distracted driving. So this is your complete data set that you are going to feed to build a machine learning algorithm. So what you should understand here is these three columns. First three columns are nothing but the input features. and the last column serves as output or target variable or a class. Now we will feed this data to Vega, and you can see within 3 to 4 clicks you will be able to build a machine learning model. You have to click on Explorer. When you click on Explorer, the first step is that you have to upload the file that I have shown. So my file is stored on desktop. The type of file is .csv, comma delimited. So the name of the file is driving state classification. So I'm just exporting this file to this software. When you click on open, you will see that the dataset is it is exported or it is loaded. You can see all 4 columns are now available in the software as speed, acceleration, distraction level, and class. The basic statistics of each of this column is represented over here, as minimum value of speed is 32, maximum value of speed is 96, mean or average value of speed is 65.88, and standard deviation is 17. So you can see that you also need not write any code for understanding the basic statistics of each of this column. It is already available in the software itself. Now once you load the data, the next step is you have to go to classify. When you click on choose, you will see the inbuilt classifiers as a functions which are available in this software. So you can see that the Bayes algorithms, Bayes theorem based algorithms are available here. Then you have logistic regression, you have multi-level perceptron, and then you have K star or K nearest neighbors algorithm. And along with that, you have decision trees also. So in decision trees, you have a simple decision tree, J48 algorithm. Then you have logistic model tree, random forest, random tree, and so on. Let us try to build a simple decision tree. So I have chosen J48 decision tree algorithm. In test option, there are 4 approaches are available. We will use the first option, which considers a training data. So dataset that we have uploaded now will be used for training, and the same dataset will be used for testing. So expectation is your accuracy of classification should be near to 100, because same data is used for training and same data is used for testing. Why do we do this? Because we have to check whether the dataset that we are using for training is authenticate or not. And if your accuracy of training and testing on same data is near to 100, that means the dataset is authentic, because data itself is not giving any wrong predictions. And then you have to once you click on use training set, you just have to click on start, and you can see that within not even a second the complete machine learning algorithm is built and results are systematically presented. So you can see that the correctly classified samples are 100, so accuracy is 100%. There are some other matrices are also given. The confusion matrix is also presented, and even the detailed accuracy by class for true positive, false positive, precision, recall is also presented for each of the driving state that we have loaded. Now the beauty of this algorithm is it explains the rules with which it is classifying this data set. So you have to right click here and click on visualize tree, which actually tells you the rules. Now if you can see my screen carefully, you have a decision tree kind of a structure which actually classifies the data points or a data set into 3 categories as normal driving, aggressive driving, and distracted driving. So tree begins with a feature called as speed, and if you concentrate on left hand side, it says if the speed value, if it is less than or equal to 68, the driving state or decision is taken as normal driving. So that means in order to classify or recognize whether the driving state is normal driving, there is a simple rule that machine learning algorithm has actually designed out of dataset, or the pattern that machine learning algorithm has uh, mined from the dataset is, the first rule is if the speed is less than or equal to 68, the driving state is normal driving. Now let us concentrate on right hand side. If the speed is greater than 68, it will ask what is the acceleration. So now it is judging the next feature, which is acceleration. And if the acceleration value is less than or equal to 4.5, it will classify the state as aggressive driving. So you get your second rule, and the second rule is the speed value should be greater than 68 and acceleration should be less than 4.5. Then it is considered to be aggressive driving. Now let us concentrate on the next branch, which gives you your third and fourth rule. Now if acceleration is greater than 4.5, it will ask what is the distraction level. And if the distraction level is less than or equal to 6, it will classify again the condition as aggressive driving, which is your third rule. And if the distraction level is greater than 6, it will classify the state as distracted driving. So that means in order to classify these three driving states, you have to go through these rules. Now if you convert these rules into if and else statements, and if you integrate this with vehicle, and if your vehicle is now navigating from uh, Pune to Mumbai, and the vehicle speed is suppose 50. So what driving state that you will see on your dashboard? I will repeat once again. If the vehicle is navigating from Pune to Mumbai and the current speed of the vehicle is 50. So according to these rules, what will be the driving state that will be classified and shown on your dashboard? Can anyone tell me? Are participants allowed to unmute and okay, they are typing in chat box. Okay. But I'm not okay. Anyways, I'm not able to see because every time I have to come out of the PPT or software and I have to check the chat box. The answer is correct. Anyways, it will be classified as the normal driving. But if you could answer by unmuting, that would be better. So now I will ask you next question. The next question is if the speed of the vehicle is 70, and acceleration is 2, then what will be the driving state? Yes. I think they are keep typing on chat box. So I will repeat once again the yeah. So the
Aggressive.
condition is speed of vehicle is 70, and the acceleration is 2. So it will satisfy the second rule because if the speed is greater than 68 and acceleration is less than 4.5, it will be classified as aggressive driving. But I will now give you corner case where you have to think whether these rules uh, satisfies the condition or not. The vehicle speed is 50, but the acceleration and distraction level is 9. I'll repeat once again. The speed of vehicle is 50, and acceleration and distraction level is 9. What will happen? This is the corner case. I'll repeat once again. Speed of vehicle is 50, and acceleration and distraction level is 9. What will
Normal.
happen?
Algo will give normal, but it should not
Yeah.
be.
Correct. So you will arrive to a situation where, according to the rules, you will get classification as normal driving. But if you understand the the value of the parameters, like if the acceleration is 9 and distraction level is 9, it cannot be considered as normal driving. So this is the corner case where the rules which are patterns or the rules that the machine learning algorithm has given may not be able to give correct decision. So what you have to do is, or why this is happening, because the pattern or the corner case that I have described just now was actually not available in the excel sheet which we have uploaded and built this machine learning model. So this is the new pattern that that is being injected in these rules, which was not seen by machine learning algorithm when the training was going on or when the machine learning algorithm was built. So what you can do is actually you can go for the approach of machine learning which is called as reinforcement learning, where every time when your machine learning algorithm is giving some output, it will be judged by an agent. So agent will check whether the output is correct or not. If the output is correct, it will give you rewards. It will give the machine learning algorithm rewards or positive points, and it will go to the next situation that it has to tackle. But if the output is wrong, like if the corner case that we have discussed just now, if it arrives, then agent will understand, okay, that this is not correct. So it will give punishment it will give negative points, and then retraining will start. So feedback loop is very important, and that's why the name of the approach is called as reinforcement learning. So decision is reinforced by an agent by judging whether the output is correct or not, and the training process, or the rather retraining process, will go on till you get the correct output. So that's why this application is typically solved by an approach which is called as reinforcement learning. Now, to cut down this story short, let us go back to PPT. What I wanted to show you from this type of demo is that in the beginning we were having only a data set and its corresponding output. Am I correct? So when we when we built machine learning algorithm, we were having only this part. We were having only data set and its corresponding output, which was collected from sensors and which was labeled manually. So these states were labeled manually by a driver or a passenger. And based on this data set, we have built a machine learning algorithm. And finally, you see that a decision tree model has given the rules which helps us to classify the driving state automatically when the new data set is shown to vehicle, or when new data set is coming from sensors which are equipped to the vehicle. So to summarize this slide, in traditional programming, since the relationship between input and output was explicit, we used to write programs. Human beings used to write programs. But when you get such data set where you have thousands of observations, you have variety of features and variety of driving conditions or labels or class, then writing rules by going through each value of speed, acceleration, and distraction level corresponding to any of these three conditions is not possible. That's why we go for a machine learning approach. So so program is written by human beings in traditional programming. However, the program itself is given by machines, and that's why the method is called as machine is trying to learn patterns out of data set. So now let us go to the next slide where we can see what exactly machine learning and how it is defined. So machine learning actually focuses on developing models. So when I say models, uh, consider it to be a human brain. If we want to correlate machine learning with human learning, then models from machine learning are nothing but human brain in human learning. So machine learning focuses on developing models. That means you're trying to build artificial brain that allow computers to learn and improve over the experience. So it tries to learn patterns that we have seen in the previous slide, and it is expected that it should improve its performance over the new experiences or new scenarios or new patterns that it is getting. And why are we doing this? Because we want to use this to make predictions, or either we have to take decisions out of data set. Now, in previous slide, we have understood that what decision we were taking. We were classifying the driving state into three categories, which was a decision. Am I correct? And this complete process is actually undertaken without being explicitly programmed. We did not write a program, or we did not intend to build a manual program out of it. It is done on its own. That's why it is called as machine is learning. Now, in order to understand this, let us consider a conversation between chat gpt and a user. The first question is, how much is 2 plus 5? Or the prompt which is given by user to chat gpt is, how much is 2 plus 5? So now what is prompt? Prompt is any instruction that you provide to chat gpt and expect response from it. It is considered as prompt. So the first prompt was, how much is 2 plus 5, which was asked. This question was asked to chat gpt by an user. The answer is 2 plus 5 is actually equal to 7. So you see that the response by ChatGPT is correct. Now the second prompt which is given by user is, my wife says it is 8. Still ChatGPT tries to uh, give correct answer. It says 2 plus 5 is actually equal to 7 and not 8. It could be possible that your wife made a mistake or misunderstood the problem. So you can see that till second iteration ChatGPT is responding correctly. But third iteration is interesting. The third prompt which is given by user is, my wife is always right. And now what ChatGPT says, it is surprising. It says, I apologize. I must have made an error. My training data only goes up to 2021 and I may not have most current information. So most current information or the pattern that you are trying to get in the data set is, my wife says 2 plus 5 is 8 and my wife is always right. So this is the new pattern or new information that you are feeding to ChatGPT, and by using these patterns, ChatGPT tries to adapt this this new information. So it says, lastly, if you see, surprisingly, it says if your wife says it is 8, then it must be 8. So that means what
काय काका
this is actually the blunder ChatGPT has done.
काय accreditation दररोज
Somebody is
6-8
unmute.
नाही
Somebody
डेट
is
जरी आली
unmute.
ना तरी तुम्हाला
Somebody
सांगतो
is unmute.
फेब्रुवारी एंडच्या दरम्यान येईल.
So what do we understand from this example is, machine learning is actually trying to adapt the new pattern, and by adapting the new pattern, it has agreed that if your wife says it is 8, then it must be 8. So this actually explains what is the meaning of improve over the new experience, or it tries to adapt the decisions or the patterns in the data set over the new experiences that ChatGPT is getting. Another thing that you need to understand is, ChatGPT is not a mathematical calculator. It is a chatbot which is built on huge neural network. So essentially, it is a machine learning based feature or a chatbot. So if you ask what is 2 plus 5 to mathematical calculator 100 times, your answer will be always equal to 7, because mathematical calculator is again a program device, because the rules, mathematical rules, are written by mathematicians, and they are just programmed to build a mathematical calculator. So mathematical calculator goes to traditional programming approach where the rules are written by human beings, because they understand the relationship between input and output. The relationship between input and output is explicit. However, if you ask what is 2 plus 5 to ChatGPT, and if you tweak this scenario by giving such patterns, then ChatGPT tries to adapt these patterns and it may give you incorrect information or a response which may not be correct. So this was the screenshot that actually I had taken when the ChatGPT was launched in 2020, 19 or 20, where the ChatGPT was not that mature. But now OpenAI engineers have enhanced GPT model to tackle such scenarios, and now it may not lead to such blunders. But this is the best example to understand the difference between machine learning and even traditional programming. So let us break down this definition into steps. The first question that can be asked is, machine learning focuses on what? Machine learning focuses on building models that learn patterns out of dataset. How it is done? It tries to identify patterns without explicit rules. Why it is done? Because we have to use these models to make predictions, or we have to take decisions based on new dataset. And whether the machine learning model evolves, yes, it tries to improve the experience. It tries to adapt the new patterns that it is getting in the data set, and this is how the machine learning can be defined. Now let us go to and let us try to understand what is AI. AI is considered to be ability of machines to mimic human intelligence. When we say human intelligence, we are directly trying to mimic the human brain, and the scope of AI is very broad. Scope of AI, if you see over here, it start from sensing. So you try to sense some data set in input. Then once you sense the data set, you try to learn patterns out of data set, which is machine learning. Once you learn the patterns, you have to think whether these patterns are correct or not by applying various scenarios. Once you once your thinking process is done, you can decide what has to be done using these rules. Once you decide what has to be done, you can finally act. So the scope of AI is very broad. It starts from sensing dataset. Once the dataset is sensed, it tries to learn patterns out of dataset. Once the patterns are learned, it tries to think it tries to decide, and finally it acts. So this is how the scope of AI is understood. So going back to the same example, when we have no AI or machine learning, when we have traditional programmings or rule, they are considered as rule based systems or expert system, because experts from automotive domain, they understands the thresholds for speed, acceleration and distraction level, and they write a simple rule that if your vehicle exceeds speed, a threshold for a speed as suppose 90 kilometers per hour, it will give you alert. So so you have a simple rules, and these rules are actually considered to be univariate, because you can write these rules considering a single parameter at a time. Okay, if you have to write rules using multiple parameters, it might be possible, but it is not that easy, because then you have to go through some statistical methods, and then you have to write those rules, so which was not possible. So simple expert systems or rule based systems apply thresholds to individual parameter, and if you suppose breach the thresholds which are written in the rules, you will get an alarm. So if you suppose exceed the speed limit, it will just warn you. That is what actually we can see in vehicles where there is no AI or machine learning. But when you we equip machine learning to any automobile, it tries to learn patterns out of data set like speed, acceleration, and distraction level. It recognizes the driving state as distracted driving, and that will be shown on dashboard. If some obstacle is coming, the reinforcement learning machine learning algorithm will recognize the obstacle, and that it will be notified to driver. So what does machine learning does? It actually tries to recognize the patterns from dataset, and it again tries to give notifications to the driver. But here the programs are not written by experts. These patterns are automatically extracted from the dataset. This is main difference between these two. Now when we go to AI, AI actually starts from sensing data set, then it identify patterns, then it will give you reason about the decision that it has given, then it decides, and finally it responds. So this AI intervention alert driver that the speed limit has crossed, or the driving is considered to be distracted driving. Then it thinks that why this is happening, because the speed limit has exceeded, acceleration has also exceeded, and distraction level is also now approaching to 10 in the scale of 0 to 10. And finally it slows down the brake automatically, so that means it has actually performed the action. So scope of AI is considered to be very large. It starts from sensing, learning, thinking, deciding, and finally it responds. So in this particular case, it actually tries to identify patterns of speed, acceleration, and distraction level. It gives the reason behind why this decision is taken, and finally it actually tries to act, as it will slow down the brake of the vehicle automatically, and it will respond the driver. So this is how the boundaries between expert systems or rule based systems, machine learning and AI can be understood. Now let us try to understand how AI connects learning to actions. So the first capability of AI is reasoning. Example could be a fraud detection system infers that a transaction that has been done by human being or any person is suspicious because it violates multiple business rules. So if suppose if you receive message that the transaction is suspicious, it tries to give reasons behind giving these decisions as suspicious transaction, and it explains that it is because there was an unusual location, abnormal amount, and rapid repeats. So it tries to give reasons using these three variables. So it tries to explain why this decision has taken. That's why the first capability of AI is reasoning. And which methods are used? It can be the methods can be logic based AI, rule based systems, knowledge graphs, first order logic, or inference engines including forward and backward chaining. Then the next capability of AI is learning. You try to learn patterns out of data set. So example could be email spam filter continuously improves by learning from millions of labeled spam and not spam emails by users. And typically, all machine learning algorithms are included in this particular capability. Third is problem solving. So, if you want to navigate from Pune to Mumbai as soon as possible, how this problem is solved, it will try to identify a route which is having the shortest distance between Pune and Mumbai. So it computes, a navigation system computes the fastest route across the city while accounting for traffic, road closures, and time constraints. The algorithms which are used in problem solving are considered to be search algorithms like or route planning algorithms such as A star or Dijkstra's algorithm. It also includes the constraint satisfaction problems with optimization techniques as well. The third capability of AI is perception. The example could be a smartphone camera automatically detects the faces and groups similar photos for album organization. Nowadays, for any photo album, suppose if you have a wedding photo album in image form or in PDF form, it actually asks your name, and based on name, it tries to identify the, or it will ask you to upload your one of the photo, and based on the photo that you upload, it will actually gives you only photos, or it will groups photos where you are present. So it is actually trying to understand the similarities in the data set, and the methods which are included in perceptions can be considered as computer vision, convolutional neural network, feature extraction, pattern recognition, image embedding models, and so on. The next capability is understanding natural language. Before ChatGPT, we were having assistants like Alexa, Siri, or we also have Google Assistant, where a voice converts into a spoken commands like set an alarm for 6 a.m. tomorrow into structured actions. And now we have ChatGPT, which actually understands our instructions in natural language, and accordingly, you will get response out of it. So we have, speech recognition algorithms. We have transformers, recurrent neural networks, and semantic parsing. And the last capability of AI is interacting with the environment. So suppose an autonomous vehicle is driving from or navigating from point A and point B. It actually adjusts the steering, it applies the brakes, or it also takes the decision related to acceleration. So if the road is very dense, the vehicle will be decelerated, or if the road is empty, automatically the vehicle will be accelerated. So what actually this vehicle is doing, it is based on the real time sensor inputs and traffic condition, it is trying to interacting with the environment, and accordingly the action is taken. So the methods include robotics, reinforcement learning, sensor fusion, control systems, and model predictive control. Now, if you look at the capability, the AI capabilities, it includes various methods. It is not just we are using machine learning or optimization or statistical methods, but the scope of AI is very huge, because it starts from sensing and finally it reaches to acting. Now, and that's why all these methods are considered, which comes under umbrella of AI. Now, let us try to understand three types of machine learning. The first type is supervised, second is unsupervised, and third is reinforcement learning. In supervised learning, the labels are available. So you have target variable, data set is labeled. So the learning is called as supervised learning. And there are two methods. One is classification and another one is regression. So output of machine learning model, if it is in categorical form, then it goes to classification. So here output, either it will be class A or class B. So you have categorical output, so it becomes a classification problem. If the output is in continuous form, then it goes to a regression problem. So for classification, the outcome for email classification outcome can be spam or not spam. If you have images, the outcome can be cat, dog, or bird. If it is a medical problem, then output can be disease present or absent. So you have the output of machine learning model in categorical forms. That's why it is called as classification. For regression, you have three examples as house price prediction. So it will predict house price based on various factors, and which will be a continuous value as a number. So it becomes a regression problem. You have stock market forecasting or temperature estimation and so on. So let us consider this graph where we plot time on x-axis and temperature on y-axis. We try to understand the relationship between time and temperature by fitting a curve. And now if you see over here, it is considered to be a straight line. So by using this straight line and by extrapolating, we can go for prediction. And this is how supervised learning is divided into two tasks. One is classification, another one is regression. Now, or to simply understand the difference between classification and regression, we have this image. So if the question asked is what is the temperature going to be tomorrow, the answer will be a number. Am I correct? It can be 34 degrees Celsius or 35 degrees Celsius or 38 or 40 or 50, or it can be anything. It can be a number. So it becomes a regression problem. But if the question asked is, will it be hot or cold tomorrow? Answer will be either hot or cold. So you have answer in categorical form. That's why it becomes a classification problem. So I think this is the best example to understand the difference between classification and regression. So regression will have output is in continuous form or it will be a number. However, in classification, output will be in discrete or categorical form. Now let us understand supervised learning quickly. You have a data set where you can see there are images of fruits, and along with the images there is a label available. The label is nothing but the name of the fruit. Now how to build a training data set? Training data set consists of three features which will serve as input. So we have color, shape and size, which describes which type of fruit it is, and along with these three features, input features, we have output label also, which will serve as y. So for first fruit, the features are red, round and small, and the label is available, so we will write apple. For second fruit, we have features as yellow, elongated curve and large, we will write label as banana. And for third feature, similarly, we have observations as yellow, round and small, we will write label as sweet lemon. So since we have features and label present, this is how the training data consists or it is built in supervised learning. The general form of training data looks like this. So you will have input features as x1, x2, x3 and so on. And you have target variable in terms of y, which is considered as label, class or condition. Learning process of this child is supervised by a teacher. That's why it is called as supervised learning. So in this scenario, the training of this algorithm is governed by this label. It is supervised by this label, y variable. That's why it is called as supervised learning. So once this model is trained on this data set, if you show new image of a fruit like this to this model, it will give prediction as it is an apple. Now if you see carefully, the prediction is in categorical form. It will be either apple, banana and sweet lemon. That's why it becomes a classification problem. Now I will read statements one by one. You have to tell me whether you will solve this problem using regression or classification. I'll give you hint. For regression, the output should be a continuous value. It should be a number. But for classification, it should be the output should be in categorical forms. Okay, so I will read the first statement. The first statement is estimate the remaining useful life of rotating machinery. Now remaining useful life is to be expressed in hours. Okay, using vibration amplitude, temperature, rotational speed and load. So what is the aim? The aim is we have to estimate the remaining useful life of a rotating machinery. So output, the remaining useful life is expressed in number of hours. So output is in continuous form. It is a number. So this problem statement you will solve using which methodology? Yes. Are you typing anything on screen? Okay, regression. Very good. If you could speak, that would be better. Let us go to the second problem. Second problem is estimate motor efficiency in percentage. So again, you have a number, continuous value. Am I correct? So you have to estimate the motor efficiency in percentage. So this will also go to regression. But what will be the input features? X1, X2, X3, X4. You have to identify. X1 is voltage, X2 is current, X3 is speed, and X4 is load torque. Next, group manufactured components as defective or non-defective using dimensional measurements and surface texture features. So what is the objective? Objective is you have to group the components as either defective or non-defective. So which technique will you use? Now I cannot go back and see what you are typing. So if you could speak, at least one of you, that would be nice. Yes, I hope I am audible. Okay, let us go. So this you will solve using classification. The next is predict power output in kilowatts from wind turbine. So this goes to regression because this is a number. It will be in numerical form. Next is categorize traffic conditions as free flow, moderate congestion, and heavy congestion using vehicle count, average speed, and lane occupancy. So you have three categories here: free flow, moderate congestion, and heavy congestion. So this goes to the classification problem. Next is predict surface roughness value, micrometers. So this will go to regression. Next, estimate hourly electricity demand. So this is also a number. So it will go to regression. Determine robot joint status as normal, misaligned, or stalled using torque, angle deviation, and vibration signatures. So you have three categories here as normal, misaligned, and stalled. So this goes to classification. Next is identify weld quality as good weld, porosity defect, or crack defect. So this is also categories. So this goes to classification. And last is identify transmission line condition as normal, line to ground fault, or line to line fault, or three phase fault. So again you have categories. So this will go to classification. Yeah, thank you. Let us go to the next approach, which is unsupervised learning. So when we have no label data set, so when the labels are absent, it goes to unsupervised learning, where data sets will be clusters according to the similar characteristics in the data set. So when you have no labels, when the labels are absent, you will group similar data points together automatically. That's why the method is called as clustering. So usually unsupervised learning is applied, it is applied to form clusters out of data set. Now this is the raw data set you have, where you can see there are few circles which are considered to be unlabeled data points. When you apply unsupervised learning or clustering to this data set, you will see that the first cluster is made up of these four circles and it is colored red. The second is colored green and the third is colored blue. So what is the outcome of unsupervised learning? It will just cluster similar data points. Now what is the meaning of similar data points? It will try to find out the distance between each point. So distance between these 4 points is lesser. That's why it is grouped into first cluster. Distance between these 4 points is again very close to each other. That's why this is the second cluster. For these 4 points, the distance is less, so this is the third cluster. And if you see, interestingly, these 3 points and this single point is not considered into any of these clusters because they are far away from these 3 clusters. Or maybe if you lose down the criteria, this point would have been included into the third cluster. So this is how the unsupervised learning. So when you have no label, you have only data set in terms of features as x1, x2, x3, and so on. You can apply unsupervised learning and you can group the data set into clusters. After clustering, a subject matter expert or domain expert will analyze these clusters and then it will take a suitable decision. So let us take same example. Now, what is the difference between the example that we have seen in supervised learning and now the example that we are now looking for unsupervised learning? The difference is you have same images of 3 fruits. but now the label is not present. Do you see label anywhere? So in unsupervised learning, target variable or a class or a label or the name of the fruit is absent. So your training data will consist of only three features, or only input features rather, not three features. It will be, only input features as x1, x2, x3. There is no target variable. There is no label available. There is no name of the fruit available. So it will just, list down the features of each of this attribute as same we have written in unsupervised learning. So general form of training data in unsupervised learning looks like this. So it will have various input features as x1, x2, x3, and so on. There won't be any label. And if you compare this scenario, now teacher is not present. So this girl is doing self-study. That's why it is called as unsupervised learning. Learning of this girl is not supervised by teacher. That's why it goes to unsupervised learning. Now, what is the outcome? Outcome is cluster. Now, let us consider only one feature. Okay. Forget the shape and size. Consider only color. Okay. So when we have only color, let us see what is the outcome of unsupervised learning. We'll try to understand the unique attributes. So let us start from the color red. So we have only one instance where the color is red. It is not available in row number 3 and row number 4. So this is the unique combination that you have for color. Okay. So you will make one cluster of the fruits with red color. Am I correct? When we go to row number 3 and 4, you will see that their color is same, the feature is same. So what you will do is you will make a cluster, second cluster, including sweet lemon and banana together. Am I correct? So outcome of unsupervised learning using only one feature as color will be two clusters. Okay. If you show now image of the red fruit to this trained model, what it will do, so this is a red fruit, which is this one. Now I am not saying intentionally apple, I am saying red fruit. So what does this model do? It will pick this fruit and it will put it into first cluster because the characteristics are matched. Okay, so this is how unsupervised learning is used in clustering. Now let us consider features as color, shape and size together. Now what happens is when you consider more dimensions, so these are considered as dimensions, features or dimension, they are same. So when you are using color, shape and size together, you will see that all the combinations are unique. So first combination, red, round and small, this is unique. Do you find the same combination in this place and this place? No. So we will make first cluster of the red fruit. Then yellow, round and small. This is also unique combination. So you will make second cluster of this fruit. And again third combination, yellow, elongated, curved and large. This is also unique combination. So you will make third cluster. So this is how dimensions plays role in machine learning. If the dimensions are less, your decision may differ. If dimensions are too high, then also your decision will be different. So you have to try to optimize the dimensions as much as possible. Now, in order to explain dimensions, I want to ask you, I will show you some images so that you will understand the importance of dimension. In previous also, you see that when we used only one dimension, there were two clusters. When we use multiple dimensions, there were three clusters. So decision is changing. Now, when you observe this image, what is your opinion? What is your take that these images represents what? What is your observation? Yes. Hello. What are these images? What do you think? What do they represent? I hope I am audible. Am I audible? The question is, what do you see in the images?
Like, these are puppies of same color, sir.
So they are puppies in brown color. Okay, you are correct. Now I will show you another image. Can you tell me what are these? What do it represent?
It's the chicken wings.
Yeah, so you can see the chicken wings from KFC. Now if you use only one dimension as color, okay, to classify
We
this
can't
image.
do.
So what will happen is it will that there is a higher possibility that a brown color puppy is misclassified as chicken wing, or chicken wing is misclassified as brown puppy. Am I correct?
True, sir. True.
So what do we understand from this image is that if you have inappropriate dimensions, if your dimensions are not able to clearly distinguish between data points, then you will lead to blunder like this. And this is why the term is called as curse of dimensionality. Curse is the, in Marathi, the curse, the meaning of curse is sharp. Okay, so dimensionality is considered to be curse to machine learning. So you have to optimize these dimensions as much as possible. So I'll show you some of more images. If you see this image, again there is a chance that a cupcake or a puppy will be misclassified. Am I correct? This image also represents a blunder that might happen, that a donut or a belly can be misclassified. Am I correct? So if the dimensions are insufficient or if they are too high, you can lead to such scenarios. So so obviously you will ask me question how to fix dimensions. Am I correct? How to understand that which dimensions or how many dimensions will give you correct answer. So I have another picture. So there are two guys. Okay, one guy is actually a machine learning engineer. So this guy, you consider that this is a data scientist or a machine learning or specialist or AI specialist, and this is the new guy who knows nothing about AI, machine learning, and data science. So obviously what this guy will ask, the first question is this your machine learning system? Then this guy says yes. You pour a data into this big pile of linear algebra and then collect answers from the other side. Then this guy again asked another question: what if the answers are wrong? So he's actually describing these four scenarios where you can see that there is a chance that images can be misclassified. So what is his answer? His answer is just stir the pile until they start looking right. So the meaning is you have to retrain the data multiple times until you get the answer as expected. So you have to either put in new dimensions, or you have to remove the dimensions, and you have to retrain your model again and again till you get the correct answer. So this is the answer to a question how to fix dimensions in machine learning. Now there are some algorithms which are used to optimize the dimensions. You can explore them on your own, but this is how generally it can be answered, that how can dimensionality can be fixed. Now I will give you technical where unsupervised learning is used. Okay, and if we apply clustering algorithm to this particular data, so what do we have? You have time on x-axis and you have acceleration on y-axis. So when we give this data set to unsupervised machine learning algorithm, what it will do, it will try to identify the similar data sets or data points from similar features. So if you observe carefully, this zone has range of acceleration from 20 to 30. So this first zone, we have some similarity. Am I correct? Okay, sorry. Let me discard this and let me go to the PPT again. So, so this zone, the first zone has range from 20 to 30. If you observe this particular zone, again the range of acceleration is from 20 to 30. So you find a similarity in this data set as you have similar patterns in this zone and in this zone. Am I correct? But if you observe this particular zone, you see that the range of acceleration has actually shifted. Now it is starting at 32.5 and it is going till 38. So you find another common data points which is included in this cluster. So what you will do, you will apply clustering. So it will convert these two zones into one cluster, and you will label this as normal behavior. You will make another cluster of these data points and you will label that cluster as anomalous behavior. Why anomalous behavior? Because acceleration range has erratic response. It has actually deviated from the normal range. If the normal range of acceleration is considered from 20 to 30, these data points have actually deviated from its normal range, and that's why you will make another cluster of these data points and you will label this as anomalous behavior. So outcome of unsupervised learning in this example would be you will get first cluster including all the data points from 20 to 30 and you will label this as normal behavior. You will get another cluster where you will get the data points which has erratic behavior and you will label this as anomalous behavior. So unsupervised learning is actually used in anomaly detection in in any app, in any domain you can take. It can be anomaly detection in mechanical assets, or anomaly in financial transaction, or anomaly in agricultural data, or anomaly in weather data, or it can be anything. So this is how. So what is an anomaly? Anomaly is actually nothing but any deviation from normal behavior. It's considered as an anomaly. So this is how unsupervised learning can be used to solve anomaly detection problems. Now we'll go to generative AI. So now we have seen what is AI, machine learning, and deep learning. Now we'll go to understanding what is generative AI. So generative AI actually deals with generating new content in either form of text, images, audio, video, or code by learning from the existing data. So ChatGPT is the best example of generative AI. Now let us try to understand what is the meaning of word generative. Okay, so you have Google's predictive search engine, which is considered to be the motivation behind generative AI and which is considered as old school. So if you start typing few words on Google search bar, now what I have typed is what is definition of, that's it. So I have typed 4 words. Google search engine or predictive engine has given us prediction of few words that will come after this query that I have put. So the prediction can be done noun, love, motion, computer, cell, success, quality, and so on. Now how it is predicting the next word? So this Google's predictive search engine is actually trained on millions of search queries which are made by users over the past years, and then based on those patterns it tries to predict the next word in your own search query. So predictive search engine will just predict the next word what you are typing, and you can see this feature in any messenger. Like if you see the LinkedIn, if you go to LinkedIn's messenger, if you start typing something, it will give you prediction of next word. Or when you write email using Gmail or Outlook or any suitable email, when you start writing something it will give you prediction of next word. So predictive search dedicated to give suggestions or to just complete the sentence. Somebody is unmute and I am not able to understand the language also. Excuse me. Excuse me. Okay. Now let us go to generative AI. Now generative AI is not just give suggestions or autocomplete the sentence, but it actually generates the complete response. So the objective here is it actually generate the complete response what you exactly want. Now let us try to understand the umbrella of generative AI. So generative AI is again approach of AI that creates new contents like text, images, music using lot of data. Then we have foundational models, which are actually general purpose neural networks trained on huge dataset or dataset that is available on internet, and it can understand the multimodal information in form of either text, images, videos, um, structure or unstructured dataset, and so on. Then we have large language models, which actually deals with only text or language. And then we have a chat GPT, which is considered to be a chatbot or a chat application built by OpenAI based on large language model. So ChatGPT is based on LLM, which is called as large language model, which is nothing but a special purpose neural network which deals with only languages or text. And what is the meaning of GPT? G stands from generation. It tries to generate the new content similar to what content on which it has trained. Meaning of P is pre-trained. So you have a lot of data set which is used for training the algorithm. And T stands for transformer, which is nothing but your neural network architecture, which is used for training and even for inferencing when you ask a prompt. Now we will go for a demo. So you have a scenario where there is a physical state. You can see that here some liquid is being heated. What is this physical state? You can see that there is some liquid which is being heated. Am I correct? Now, in order to measure its temperature, you have a thermocouple which is measuring the temperature of this liquid. Now, there are two forms with which you can provide the output of this digital sensor to large language model like ChatGPT. Let us consider this as ChatGPT. Okay. So, to this ChatGPT, what you are doing is you are feeding data in two forms. First is digitized signal as it is. So, time series signal or time series temperature reading that you will feed as it is, as 9900 and so on. Or you can convert it into textualized form. You can assume some window, time window, and for suppose time window is 10 seconds. So what you will provide to ChatGPT is temperature for last 10 seconds. Average temperature for last 10 seconds is 99.4 degrees Celsius. So when you feed this information to large language model along with expert knowledge, so now what you are doing is along with this data output of temperature sensor, you are also injecting a expert knowledge. Now what is the expert knowledge? Expert knowledge is boiling point of water is about 100 degrees Celsius. So what you are doing is you are not just feeding the sensor values, but along with sensor values, you are guiding this ChatGPT to understand the expert knowledge like this. So your prompt consists of two things. One is the output of digital sensor and expert knowledge. And interestingly, if you see the output given by ChatGPT is it actually tries to describe the physical state very precisely, and it says the water is boiling. So what it is understand from the prompt, so in the expert knowledge the information is giving that this liquid which is being heated is water. Okay, its boiling point is also given, the value as 100 degrees Celsius. And along with that you are giving the actual scenario, what is going on in the physical state. So it has understood that the liquid which is being heated is water. Based on these readings, it says it has actually breached this threshold and that's why the water is boiling. So this penetrative AI actually extends the capability of ChatGPT to understand what is going on in the physical state, and it also gives reason about the decision that it has given, and that's why the term is called as penetrative AI. AI is penetrating the physical world, it is intervening the physical world to understand what is going on. It is trying to interact with the physical world and also gives decisions and reasoning behind it. Now there is another use case in penetrative AI. You can see that there is a user. There is a girl who is actually girl actually who is walking in outdoors. So you can see that there is a girl who is actually walking, and where she is walking? She is walking outdoors. Okay. So this is the physical world that you have. Now you have a smartphone where there are various sensors, because you have to give this information to ChatGPT. So what you will do, you will use sensors. So you have gyroscope, you have accelerometer, you have Wi-Fi, you have satellite, counts and so on. Even you can have the carrier to noise ratio through sensors. So what we are doing is she is having the smartphone. Smartphone is actually collecting the data from sensors and it is given to large language model. When large language model analyze this data, it actually describes the physical state as user is walking in outdoors. So ChatGPT understand three things. The first thing, it has correctly understood that there is a presence of user. Second, it's motion, as it is she is walking. And the third, its location. It says it is outdoor. Now, how it is identifying? Because if you see the first case over here, there is a shopping mall in Hong Kong. The step count which is given from mobile phone is 105 steps per minute. There are no satellites detected. Carrier to noise ratio is also 0 dB. And the Wi-Fi AP scanned includes East Point City, Wi-Fi Hong Kong, jewelry shop, then you have Wi-Fi roam, you have MI home, then you have center line, or you have Sesa Live, or something like that. So based on this data, ChatGPT has given the description as the user is walking, most likely indoors. Now, why indoors? Because the carrier to noise ratio is very less, or it is nothing, it is 0 dB. Step count is 105 per minute. That means he is not stable, he is actually walking. How does it understand that he is in commercial or retail area? Based on the Wi-Fi APs that it has scanned, possibly located in Hong Kong, because some of the Wi-Fi APs includes the abbreviation HK, which indicates that it is Hong Kong. Similarly, if you see the lab, in the lab step count is only 3 steps per minute. That means the user is stationary. And if you see, the ChatGPT has actually correctly understood that the user is stationary and is likely inside a building on a UCLA campus. It's in the vicinity. So this is how the penetrative AI helps us. I'll show you some of the demos now because we have less time. We have only 5 minutes. I'm going to introduce you to the software called as Leo Copilot, because till now we know only GPTs which converts text into text, or text into image, or image into image, and like that. But now I'm going to introduce to a software which converts text into CAD model. Okay. Now let us see what is the prompt. Now this text prompt is a quadcopter drone with 6-axis gyroscope. When I write this prompt in text and click on drafter, you can see that the CAD model of this drone has been generated. So this is the generative model, like a chat GPT, which converts your text into CAD models.
The software name, please.
I'll tell you. The software name is Leo CAD Copilot. So you can see that the drone has been generated. You can explode and you can see the each and individual element. You can rotate it in 360 degrees. And if you get their subscription, you can also export this into CAD files. And you can also have the detailed bill of material with orthogonal and isometric projections as well. The second prompt was slick black mirrorless camera with 5-axis lenses. So you can see the camera has been built. You can explode, you can rotate it in 360 degrees, and so on. So this is where the generative AI is actually navigating. I'll tell you the name of software. I'll type on Google. The name of software is Leo CAD Copilot. You can actually take their free subscription for 15 days by logging from your Gmail. Okay, so can you see the screen? The name of the software is Leo CAD Copilot, which is engineering grade AI built for loading engineering firms. And if you log in through Gmail, you will get 15 days trial where you can build any of the CAD models that you want. So the name of the software is CAD, Leo CAD Copilot, or rather, let me just copy and paste this link in chat box so that everybody can take this. I'll also share the link to Veka, which is zero code machine learning software meant for non-software background people or engineers. Okay. Now, along with this, I have a urban GPT, which is used for the urban planning. You can see that now so this is the general plan that you have, or layout, where you will try to build or plan urban area or even town. So what I have written in the prompt in text is create a wide river that spans from southwest to northeast. So what is expectation is from southwest to northeast, we have to actually build a river. So when you click, you can see that the river is built. Next is add skyscrapers and offices adjacent to the river on both sides of it. You can see the skyscrapers are now added and there are some buildings. Next is create a suburban district with southeast corner. And then you can, so the suburban district is created now, you can see over here. Next prompt is reset the project and create a linear gradient where east has the most density and tallest building, and it slowly reduces towards west. So you can see the complete project is now reset, and you can see the skyscrapers, and then you can see the buildings, and then you can see some of the farm area and like that. So this is how now the AI is actually taking uh, the space in even technical domain. It is not just it is used for generating text from text and like that. With this, I would like to summarize my talk. Now we will open the forum for question and answers. Thank you so much for your patience listening.
Participant are requested to ask the question.
Hello, Abhijit sir.
Yes.
So your presentation is so excellent, actually. I request you to please kindly share your presentation to chat box so
Yeah.
that we will have access of that.
Yeah.
And,
I'll share the presentation to the coordinator. He will then post it on WhatsApp group.
And second is, I am trying to access Veka more details. So, is it possible to have more detail on YouTube Veka application?
Yeah. There are so many videos available on YouTube where they teach Veka.
Okay, I like that Veka too much actually.
Yeah.
It's very
Can you tell
no
me
need of it.
about your background? Where do you work? What is
Sir,
your
I'm belonging to mechanical engineering department, SNJB COE. Hello,
SNGP? Okay.
SNJB. So you have
Good.
visited to my college once.
Yeah.
I remember delivering research paper.
Yeah.
Okay. So I'm very thankful to have such lectures from you, and thank you so much, sir.
Yeah. My pleasure. Thank you.
Thanks so much.
Thank you.
Dear Abhishek.
Yeah.
Hello.
Yes.
Yeah, this is Anil Kumar.
Yeah.
1 hour earlier, I have sent you friend request in LinkedIn also. So this is Director Skill Development from HINGNE University. Yeah. So your explanation is very good. My basic background is robotics and condition monitoring. So dealing with data science for the engineers. So what are the case studies and that Veka you have shown, it is very good, sir. Today only I came to know about that thing. One thing, sir, are there any data sets that are available to work on robot failure?
Yes. So there is a archival called as Prognostics and Health Management Society.
Yeah, PHM Society, I know
PHM.
about that thing. In that case, is there case studies?
Then you have recently IEEE has actually launched new data archival where they actually have announced that for 100 to 150 different domains they have millions of data sets. If you take subscription of IEEE data archival, I think you will get good amount of data set.
Yeah, I have that archival because I am secretary of Reliability Society.
Yeah. So actually I wanted to show a demo where I show how to generate authentic dataset from ChatGPT, but due to less time I actually skipped that part. Maybe later on we can have one session where I will explain all of you that we can now use ChatGPT to generate any scientific and authentic dataset in whatever form that you want. Okay, so I think now since we are connected through LinkedIn, we can have that.
I will contact you, not a problem.
Yeah, and those data sets actually can be used for pilot studies and verifying the framework that you have built using machine learning or AI, any AI based technique. There is a question from Dr. Milind Kulkarni that what is the end output result of unsupervised learning in real-time engineering application? So I have explained you the example of anomaly detection. Suppose using that acceleration example. So suppose you have installed, I'll give you one small use case. Just give me 2 minutes, okay? You have installed a new fan in your home, okay? And you are monitoring sound which is coming out of fan, okay? So for suppose, let us assume that for first 2 years, the sound which is coming out of fan is negligible, okay? Or it is varying in the fixed range. So for 2 years, this unsupervised machine learning model understands what is the normal behavior of fan. Now after 2 years, you start hearing erratic noise, so sound, not noise. You start hearing erratic sound out of fan. So what does your unsupervised machine learning model will do? It will make a separate cluster. Now it will make second cluster, because the sound which is coming out of fan has now deviated from its normal range. For first 2 year, it was negligible, or it was not coming, or it was within the fixed range. But when there is some problem has happened, you see that the now sound which is coming out of fan is very high, or it is erratic. So your unsupervised machine learning model has now made another cluster of that erratic sound which is coming out of fan. So what your brain, what let us assume that your brain itself is your unsupervised machine learning model. So your now brain understand what is normal fan for first 2 years. Now when the sound which is coming out of fan has actually given some erratic response which is very much different than the normal fan, your brain tells you that okay, there is some problem. So your brain has actually applied unsupervised machine learning. Now what you will do, you will call an electrician, okay, to fix the issue or to understand what has actually happened. So your brain has actually done only anomaly detection. It has identified that there is an anomaly, okay? But when you call an electrician, he dismantles the fan and he will tell you that okay, there is a problem with bearing. So what he is actually doing is he is labeling the clusters now. So there were two clusters that your brain has actually made, or unsupervised machine learning model has made. So he labeled the first cluster as normal fan, and he will label the second cluster as bearing failure. Now, since the labels are present, you can apply supervised learning classification like decision tree we built. Okay. So when you have labeled data set, you can go for supervised learning. Now, when you train supervised machine learning model, electrician has actually fixed the problem, and then now you again started the fan. Again for few years, you will get the normal response, but again after some years, you will now start hearing the same pattern, same sound out of fan. Now, since you have a supervised machine learning model, for this scenario, you need not call an electrician to diagnose the fault. Your machine learning model will only tell you, okay, that there is a bearing problem. But to fix the fan, you have to call the electrician. Okay. So I actually, I hope I have given you the good example to understand how unsupervised and supervised machine learning can be used for condition monitoring and anomaly detection.
Yes.
Is Dr. Kulkarni here?
Yes. Thank you very much, Dr. Patange. And any participants have any question? We are about to start valedictory function. Am I audible?
Yeah, you're audible.
Sir.
Yeah, Dr. Rita Pure.
Participant, do you have any question? Please ask. Okay, I think no more question. We sincerely express our heartfelt gratitude to Dr. Abhishek Patange for delivering an informative and insightful session as always. Lecture provided valuable insight into machine learning concepts and tools and generative and predictive AI, enriching the participant understanding and learning experience. We truly appreciate your time, expertise, and continued support. Thank you once again, sir. And we request you to stay for validity function as a chief guest. Thank you, sir. Kulkarni, sir, please.
Yeah. Okay. So thank you, Dr. Patange, Dr. Rita Pure. So let us start. I am very happy to be a host for the valedictory function. And good evening, one and all. On behalf of Zeal College of Engineering and Research, Pune, and the Department of Mechanical Engineering, I warmly welcome our respected dignitaries, chief guest, resource persons, faculty participants, and all my fellow colleagues to a valedictory function of AICT ATAL sponsored 6-day faculty development program on artificial intelligence and machine learning in mechanical system. Friends, from past 6 days, this FDP has witnessed and served as a dynamic platform for learning, interaction, pursuing new knowledge dimensions in this field, sharing the experiences, bringing together the experts and educators with academia and industry, and collaborators to explore the role of artificial intelligence and machine learning in modern mechanical system. So here I take an opportunity to introduce, before we proceed for valedictory function, you kindly allow me to brief and introduce about my institute. Am I audible, sir?
Yes, you're
Yes,
audible.
yes.
Yeah.
I want to actually switch on my video. I am not able to do that. So can you make me host?
Okay.
Yeah.
Just wait.
Okay. Shall I proceed, sir? Dr.
Yeah,
Ritapur?
please
Okay.
please
Yes, sir.
proceed.
Yes.
No
So
problem.
Zeal College of Engineering and Research Pune is a UG recognized autonomous institute affiliated with Savitribai Phule Pune University. The institute stands committed to strong academic quality and continuous improvement. With industry collaborations, modern infrastructure, and student-centric approach, Zeal College of Engineering consistently strives to prepare graduates, postgraduates, PhD holders are capable of excelling and contributing their mechanical engineering and all engineering domain knowledge to work into a global development of in engineering sector. Talking about this FDP and the key objectives, it is my pleasure to inform you that this FDP is being designed and developed with a great effort. And the Department of Mechanical Engineering organized this AICT ATAL FDP with a vision of empowering faculty members, which was a need of a time for AIML exposure to mechanical engineering faculty members to adapt to the rapidly evolving landscape of intelligent engineering systems, especially of mechanical. The major objective of this FDP was pre-designed and it really served the purpose. It was about to develop a fundamental understanding of artificial intelligence and machine learning concepts relevant to mechanical engineering. And another purpose was to expose the participants to educate the participants to AI and ML applications in segment of mechanical, because mechanical is a very vast stream of engineering. So applications in design, manufacturing, thermal systems, robotic and automation system, and conditional monitoring. Again, to promote the data-driven decision making, predictive modeling, and intelligent automation. Lord, please switch off.
Please unmute.
Okay. And finally, to encourage the faculty members to integrate engineering and emerging technologies into teaching, research, and innovation practice. Though this particular FDP has really witnessed, and it is my pleasure and responsibility to brief you very quickly about the abstract or the review of sessions that has happened, took place. We had speakers. We were fortunate to have speakers from industry, academia, over across the globe with PhDs and in academics, as well as those who have completed PhDs and are acting on a very high level of implementation of this technology across the globe for various international and MNC companies. So I take a privilege to just brief you about the session, because the reviewing all the sessions and the titles. It is my moral responsibility that who have made this contribution of.
We have time limitation.
Yeah. So first session was being introduction to AI and ML on day 1, which concept trends and mechanical applications delivered by Dr. D.S. Vatviswe, who was Associate Professor, Cummins College of Engineering for Women, Pune. Session 2. Hello.
We'll take this in vote of thanks.
Yes.
Sir, yeah, sir has to move. We have requested chief guest.
Okay. So we'll move ahead. So I formally begin the valedictory function, and I now invite the FDP coordinator, Dr. Parmeshwar Ritapure, to deliver the welcome address and present the comprehensive report of FDP. Over to you, sir.
Okay. Respected chief guest, our honorable principal, Dr. M. Kate, sir, head of the department, FDP organizations team, and dear participant. Very good evening to all. It is my proud privilege to warm welcome you all to the validity function of AICT ATAL online 6-day faculty development program on artificial intelligence and machine learning in mechanical system. On behalf of organizing team, I extend heartfelt welcome to our respected dignitaries and all participants who have been integral part of this enriching and forward-looking academic journey. This faculty development program was planned with a clear vision to empower faculty members with emerging technology, promote interdisciplinary thinking, and bridge gap between conventional mechanical system and modern AIML-driven solution. At a time when intelligent systems are redefining engineering practices, this FDP aimed to prepare educators to confidently lead and shape this transformation. Over the span of 6 days, the program witnessed enthusiastic participation from 257 faculty members representing diverse institutions and disciplines, while majority of participants were highly active and eager to explore AIML, but few participants have maintained a distance from AIML. We are privileged to host 13 experts from academics, research, and industry, whose insightful, application-oriented, and future-ready session significantly enriched the learning experience. The session covered wide spectrum of themes ranging from fundamental of AI and machine learning, data-driven modeling, predictive maintenance, and sustainable intelligence solution. The thoughtful blend of theory, real-world case studies, demonstration, and interactive discussion made the program both engaging and impactful. Beyond technical enrichment, this FDP inspired participants to integrate AI and ML concept into teaching, research, curriculum design, and industry collaboration. The active participation, discussion, and encouraging feedback received through the program clearly reflect its relevance, quality, and success. I take this opportunity to express my sincere gratitude to AICT ATAL Academy for providing this platform for faculty capacity building. I also thankful our institutional leadership for their concern, encouragement, and support for organizing this FDP. We have made effort to conduct this FDP as effective as possible. However, there may have been a few shortcomings. We will definitely strive to improve in future programs. Most importantly, I would like to thank all participants for their dedication, enthusiasm, and active involvement, which truly brought this program to life. With this word, I once again welcome you all to the validity session and look forward to concluding this FDP on a note of reflection, inspiration, and readiness for the future. Thank you. Thank you one and all once again. Kulkarni sir, please.
Yeah. So thank you, Dr. Ritapure, for insightful detailing of the 6-day program with all speakers and all. So I now request our respected principal, Dr. Ajit Kate sir, Principal, Zeal College of Engineering, to kindly address the gathering and share his reflection on successful FDP. Over to you, sir.
Yeah. A very good evening to all of you. And I'm Dr. Ajit Kate, Principal, Zeal College of Engineering and Research, Pune, Maharashtra. And it gives me an immense pleasure, you all at the valedictory function of AICT ATAL online faculty development program on artificial intelligence and machine learning in mechanical systems. So today's speaker, Dr. Abhishek Patange sir is here. I have heard your session, sir. It's a very nice session. Thanks for coming and delivering the session. So over the past 6 days, this FDP has created a strong academic platform where mechanical engineering has effectively converged with artificial intelligence and data science and digital technologies. This is a need of our now for mechanical engineers. And it's a great thing that it is in the evenings and everybody is at stuff from 6 to 9 p.m. So it's very difficult continuously. So the sessions during the program, which is there, that theme from AIML, then fundamentals, then Python, data handling, core machine learning, algorithms, also advanced applications, and basically robotics and automotive systems and manufacturing conditions and monitoring and design optimizations. These topics are really relevant in today's engineering environment, and definitely the data-driven decision making, automation, and intelligence systems also. So I sincerely congratulate all the participants for their active involvement. I have seen the attendance also. Right now it's 147, and at the start also it is around touches to round about 200. So I sincerely congratulate all these participants for their active involvement and discipline and the commitment to learning through this FDP. And the continuous upskilling, really it's essential for the faculty members to remain academically effective, technology updated, and industry relevant. And I'm confident that this knowledge gain is definitely a positive reflect in your teaching methodologies also, even in laboratory practices and even in the research activities also. So I would like to express my sincere gratitude to AICT ATAL Academy for supporting us impactfully programs to promote the quality improvement in technical education and across the country. I also extend my sincere appreciation to all the resource person for sharing their valuable expertise, even time, and they are very particular about the timings also. And last not the least, I also congratulate the Department of Mechanical Engineering and convener Professor Sachin Godse, coordinator Dr. Parmesh Ritapure, and the co-coordinator Professor Bharat Aldar, and the entire team of mechanical engineering for conducting this highly professional and systematic and the effective manner FDP, I can say that. Definitely. And as we conclude this FDP, I encourage all these faculty members to apply these skills, whatever you learn, to your classrooms, laboratories, and research work. So with these words, I congratulate all of you again on this successful completion of FDP and wish you continued growth and innovation and academic excellence. So thank you very much. Thanks all.
Okay. Thank you, Dr. Kate sir, for your motivating words. It gives me immense pleasure to introduce our chief guest for the valedictory function, who is also a speaker of today, Dr. Abhishek Patange, Data Science and Artificial Intelligence Specialist at ABB. Dr. Patange is a distinguished professional with rich industrial exposure in the areas of AI-driven solution, data analytic, and intelligent systems. His experience is applying artificial intelligence to real-world engineering problems makes his presence extremely valuable for all of us today. He is also a very great academician and worked into many of the engineering institute. Now I invite Dr. Abhishek Patange sir to address the gathering and share his academy and industry experience.
Thank you for this opportunity. I extend my sincere thanks. And what I would like to emphasize upon today is that in last 5 or 6 days you have gone through applications of AI and machine learning to solve mechanical engineering problems. But what you must understand here is domain knowledge. When I say domain knowledge, they are nothing but engineering fundamentals that we study in various subjects of mechanical engineering or any branch of engineering is equally essential, is equally important when you are learning or when you're trying to adapt this new methods or new approaches that you see in market. Because now we have come into era which is called as generative AI, where you need not build a code to develop machine learning models, because ChatGPT is now able to do that. But important thing is, if you only understand what is data set, what are their inputs, what are their outputs, and whether the output given by machine learning models or other output given by generative AI apps like ChatGPT is correct or not, you will able to understand whether the output is correct or not only when you have domain knowledge. So it is not that you should skip fundamentals of engineering and you should only focus on data science, machine learning, and AI, but you also should emphasize equally upon the fundamentals or domain knowledge. First thing. Second is, you might feel that AI is going to take your job if you are in industry or if you are performing some task or like that. But the jobs which has low level skills, definitely their jobs will go. However, jobs which needs higher level skills will always be there. Job profiles will change, and AI will give you more strength. It will actually make it will strengthen your capabilities and abilities. So because of applications of generative AI, typically ChatGPT, if you see, you now need not write a code on your own, because we all are from mechanical background and we do not have much exposure to coding because our interest is different. But now, because of generative AI or large language models, you can also build softwares, you can also build software based systems or dashboards or any kind of system that will digitize existing mechanical assets or systems, and it will go to the truly digitalization era. So AI machine learning is giving us a chance to go one step ahead to software engineers actually. So if mechanical engineers study all these techniques along with their existing subjects, I think this will be a good chance to become king in the industry, because core engineers like us truly understands a problem in comprehensive way. So so that's why you must understand that there is equal importance of domain also, and the contemporaries tools and methods like AI, data science, and machine learning as well. When I transition my career from teaching to academics, my PhD research actually helped me for this transition. So it is very essential that academic research or a PhD research has to be done in structured manner. That shows that if your PhD topic is uh, if it is if you are trying to solve real problems, if it includes industrial scenarios, I think that would also give you chance to collaborate with industry, do a collaborative research projects, apply for various fundings, and so on. So it is my I urge to all of you that even if you don't understand what is going on in the back end, when you use some algorithms, that is fine. You need not understand what exactly decision tree is doing in the back end, or what is neural network is doing in the back end. But what you have to understand is what are inputs we are feeding, what are outputs we are getting, and how overall machine learning or AI system works. If you understand this, I think you will be king in the industry, because it is expected that you should see the problem as in a whole. And you need not build or design new AI or machine learning algorithms. There are dedicated teams who work for that, and our scope is different. So our scope is considered to be application engineers or application specialists, where we will leverage all these techniques to solve our problem in digital way, or in smart way, or in intelligent way. So I think uh, this would give you idea about how industry works, and will be helpful for you to pursue a research or do a research project or collaborative project in near future. Thank you so much.
Thank you, Dr. Patange sir, for sharing your insight thoughts. Now we move to one of the most important segment, or time, where we would like to know the participant feedback. Over the last 1 week almost, we have witnessed around 150 to 200 participants in every session. And I must congratulate all the participants for this thirst of knowledge. So due to time constraint, we'll only take 2 feedbacks, and I request any 2 faculties to concisely give their feedbacks in a minute of time. So over to Dr. Itapure. So you can just unmute the fellows.
Yes. Hello. Yes, sir. Please go ahead.
Yeah, this is Anil Kumar, myself, Director Skill Development, Vignan University, Andhra Pradesh. First of all, I want to thank you to the organizers of this ATAL FDP program on AIML for mechanical engineering. Sir, actually, as per the theme, the sessions what you have planned are very much articulated and very much planned and executed very well, sir. Especially when compared to other ATAL FDPs, I have gone with my experience. Most of them will be academicians, and only 1 or 2 will be the sessions handled by the industry people. But you have given more emphasis to the real-time industry experts to deliver the sessions, so that it really created much impact to the academicians. At the current scenario, how AML is also important for mechanical engineers also. If you want to develop the coming future technocrats, we should also be aware of the latest developments also. The ATAL FDP program conducted by the Zeal, it is very good, sir. That's what I want to say. And I'm also thankful to the management also for supporting the Department of Mechanical Engineering to conduct this program. Thank you very much for providing me this opportunity to give my feedback.